Section 3.5 is inequalities in triangles. So by the end of class, you should be able to answer is, can a triangle be formed by any 3 side lengths? And if you were in class today, you would have been able to potentially get a piece of spaghetti. So if you're at home, you could do this. If you have a box of spaghetti and your parents don't mind you opening it, open a box of spaghetti. You only need 1 piece and break that into 3 pieces. So you're going to make 2 breaks into your piece of spaghetti. And then actually try to make a triangle with them. So if you pause the video and you're back from trying that little experiment, some of you would have been able to make your spaghetti or to make your triangle out of your spaghetti, but others of you would not have been able to. So that's sort of what we're doing today, is that unfortunately, not every 3 random lengths will always enable you to form a triangle. So we're going to start with a little bit of an exterior angle inequality theorem. So we know the exterior angle theorem says the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3, where 3 is my exterior angle and 1 and 2 are my remote interior angles. Okay, so what the inequality says, because it's a little bit different, it's pretty much the same thing. We're just not going to have an equal sign. It says if an angle is x, an exterior angle of a triangle, then its measure is greater than the measure of either of its corresponding remote interior angles. So we look at this diagram. My exterior angle is angle 1. So we know that angle 1 is bigger than angle A, and angle 1 is also bigger than angle B. And that should make sense to you because it takes me adding A and B together to just get it to equal that exterior angle. So that means the exterior angle must be greater than both of those. All right, so think back to a couple days ago. Probably would have been better for me to insert it in this section. But a couple days ago we went over and we said the largest side is across from the greatest angle. So that's something we need to think about. So because it says list the angles in order from least to greatest. All right, so we want least to greatest, so smallest to biggest, so the angles. So if I have a side, I look at my smallest sides, okay? 6 is my smallest side. So the angle that is the smallest is going to be across from that. So the one that's opposite it. So angle T is going to be the smallest. My next largest side, or my next smallest side, I guess I should say, is 7. So the angle that's opposite 7 is what's next. So angle R. And finally, my biggest side is 9. So the angle opposite that is angle S. Another way I sometimes tell kids to do it is say, okay, my smallest side is SR, my middle side is ST, and my largest side is RT. So to get the angles that are the smallest, or to get your angles, you simply use the letter that's not there. So for SR, angle T is the one not used, ST, angle R is the one not used, and RT, angle S is the one not used. You can see those both match. Okay, so it's sort of the same for the opposite now. So now they're going to give me the angles and ask me to list the sides in order. Okay, we're listing the sides in order. Last time we did the angles. They're not going to give you the angles and say list these angles in order. We're not in 2nd grade anymore. We know you can put basic numbers in order according to least to greatest or greatest to least. So if they give me the angles, they want the sides. So angle A is the smallest. So we want shortest to greatest, or shortest to longest. So angle A is the shortest. Angle C smallest. Angle C is the middle angle, and then angle B is the largest, coming in at 125 degrees. So we could use that same concept we did over here. So if it's angle A, so that means BC must be the smallest side. Since C is my next angle, I did not use A or B. And since B is my largest angle, that means AC. If we're referring to the picture, because to me the picture makes more sense, but I know when I've taught this before, sometimes that first way makes the most sense. Angle A is my smallest, so the side opposite that is BC. Angle C is my next one, so the side opposite it is AB. And finally, angle B is my largest angle, so the side opposite that is AC. Okay, so you really need to pay attention and read directions. All right, the triangle inequality theorem says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. For example 3, it says the measure of two sides of a triangle are 5 and 8. Find a range for the length of the third side. So since we don't know the third side, we're going to list all of our sides. So 5, 8, and x. So now we have to create 3 inequalities. So we add 2 of the sides and make it greater than the third, and then switch the numbers around. So next I'll do 5 plus x is greater than 8, and finally we'll do x plus 8 is greater than 5. Right, so now we just need to solve them. So we get 13 is greater than x. If I subtract 5 from both sides, I get x is greater than 3. And if I subtract 8 from both sides, we get x is bigger than negative 3. So if we think about the negative 3, that would mean like negative 2, negative 1, 0, negative 1/2, or any fraction or decimal. And we can't have the length of a side representing a negative number or a negative value, or have it equal to a negative value. So we can disregard that whole last inequality. And that will happen every time. So if we go through here, now we're going to write this as a compound inequality. So it's going to be 3 is less than x, which is less than 13. Or x is between 3 and 13. It cannot equal 3, cannot equal 13. It has to be between them. All right, example 4. It says determine if the following values could be lengths of sides of a triangle. So that's going back to the triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So we take the two smaller sides, so 2 plus 4, and that must be greater than the third side. Put a little question mark above there because we're not quite sure. So we get 6 is bigger than 5, which works out. So we can say yes, it forms a triangle. All right, so if we get 1.5 plus 2.5, that needs to be greater than 3. So we get 4 is greater than 3, which again is true. So we're going to say yes, it's a triangle. Now, one thing I do want to keep in your mind is that if I were to say get 10 is greater than 10, that's actually not true. Okay, 10 is equal to 10, it's greater than or equal to, but it is not greater than 10. So if you had that, we would say no, not a triangle. All right, so do keep that in mind. All right, the last example says determine whether the given coordinates are vertices of a triangle. Explain or show your work. So you do have the option, if you click the little plus sign and then stickies, and then grids, and I'm just going to make it bigger. If I clicked paper, I can make my squares a little bit smaller. You can change the background color, move it around. So I'm not going to do this, but if I were to graph the coordinates on the coordinate plane, you would then need to write an explanation as to say how you know it is a triangle. So that is an option. However, sometimes graphing is not our best option, so I'm going to show you how to do it using algebra to prove that it actually does form a triangle. So the first thing we need to do is find the lengths of sides. All right, so if we're finding the lengths of each of the sides, I'm going to start off with AB. right, so I'm going to skip some steps here. Distance formula, I get 3 minus a negative 4 gives me plus 4 squared. Plus 3 plus minus a negative 1 gives me plus 1 squared. Don't forget those square roots. So we get 7 squared, so 49 plus 16. So we get the square root of 65 for AB. If we're looking at BC, I'm going to do 5 minus 3 squared plus negative 6 minus 3 squared. So we get 2 squared, which is 4. We get negative 9 squared, which is 81. So we get the square root of 85 for B to C. And then finally A to C. We get 5 minus a negative 4, so 5 plus 4 squared. Negative 6 minus a negative gives us a plus 1 squared. So we get 9 squared, which is 81, plus negative 5 squared, which is positive 25. So we get the square root of 106. All right, step 2. We're going to use the triangle inequality. Right, so use the triangle inequality to determine if it is a triangle. So that means we're going to take our 2 smaller lengths, so the square root of 65, plus the square root of 85, and is that greater than the square root of 106? So if we do this, type this in the calculator, we end up getting 17.28 is bigger than 10.3, which is true. So we can say, yes, it is a triangle. All right, so I would pause the video, try the your turns. I'm just going to go through and write the answers down for you.